Today we're going to look at characteristics of quadratic functions and their graphs. As you go through this, just copy down the notes. We'll discuss in detail some examples once we get to class, but right now this is mainly to get you the information that you need so that we can have a good discussion once class begins. This will save us a ton of time as far as the explaining and the definitions. So we'll start with what a function is. A quadratic function is any function that can be written in the form y equals ax squared plus bx plus c. And you should remember that from the beginning of the year when we talked about functions. But the key to that is the square. Now you don't have to write that, but the key to that is the square there. That's what determines whether or not it is quadratic. And of course it says where a does not equal 0, because if the a was equal to 0, there would be no x squared. Therefore it would be linear. The graph of a quadratic equation is called a parabola. Not parabola, but parabola. You've seen those around before. We'll talk about in class some different examples of where you've seen them, but think about that. But it's called a parabola. Next, the quadratic parent function, you should remember this from earlier in the year, is y equals x squared. Again, the squared is what makes it quadratic. Now, there are two parts we're going to talk about first. We're going to talk about the vertex, and the vertex is this point right here. You've heard of vertex before. You've heard it probably in terms of vertices when you talked about different shapes. But the vertex is either on a parabola is either the top or the bottom. More importantly, it's where the direction changes. So I always put that in the notes, where the direction changes. So if you look at one, like the example here, if you look from left to right, it's going down until it hits the vertex, and then it starts going back up. Another example, you don't need to write this, would be like this one, where it starts on the left and it goes up till it hits a point, which is the vertex, and then it begins heading back down. And the second term we're going to learn is axis of symmetry. You've probably heard that term symmetry before. The axis of symmetry is this middle line that runs right through the middle. So I've put center line runs through the middle. It's kind of like the mirror line. You've seen it before. We've talked about in middle school. You talked about axis of symmetry, like a square would have two axes of symmetry. Well, now with a parabola, we have one. It's called the axis of symmetry. Now, they each have a formula that we're going to use, and this is very important that you write down. The formula for the axis of symmetry, we call that the AOS, and I'll write that first, is x equals negative of b over 2a. Now that negative b over 2a comes from the quadratic function that I wrote at the top, y equals ax squared plus bx plus c. There's the a, there's the b. It's the coefficient of the x squared and coefficient of the x. We don't need the constant in determining the axis of symmetry. And then the formula for the vertex, it really isn't a formula, but it's a pattern you can follow. The vertex is a point, so we need to look at it as a point. And that point is the axis of symmetry, the x, because it is x equals, and then whatever the range is. And I'll show you how you can put that in later. And finally, I want to show you an example of one that we can kind of work through and find at least the axis of symmetry we can find here. We'll look at x squared plus 4x. Notice there is no constant, so that's really like plus 0, but I didn't write it this time. And in this case, a equals 1, b equals 4, and c equals 0. So using the formula, I'm going to have x equals negative b over 2a, which is negative of 4 over 2 times 1. And if I simplify that, that becomes negative 4 over 2, or simply negative 2. So that means the axis of symmetry is x equals negative 2. Now, I'll explain this again in class, but you need to know that when you write the axis of symmetry, it is a line. So if you just put negative 2, that is incorrect. You must write x equals negative 2 if I ask you what the axis of symmetry is. Next, we'll take a look at some very important characteristics, the x-intercepts. The x-intercepts are the points where the graph crosses the x-axis, obviously. We also call them the zeros, the roots, and solutions. They all have different words for the different meanings the different times you look at them. But if you look at a graph and you find the x-intercepts, then you have actually found at different times, you found the zeros, which has a meaning we'll get to later, the roots, or the solutions. Solutions comes from meaning it's the answer, basically, what makes it a true statement. We just did systems of solution or systems of equations and inequalities that had solutions. In this case, a solution is two specific points that will come back and be very useful later, but you can find them by looking at specifically the x-intercepts. Now, when graphing or when looking at a graph, there's three different options you have. You can have absolutely no x-intercepts, so it means no solutions. Those kind of look like this, where you have a parabola that's above the line or the x-intercept or axis, sorry, or below it. You have the option where sometimes there's only one, and in that case, the vertex is actually the only point that is on the line. Barely didn't draw that one real well, but you get the point. And then the third option is you could have two x-intercepts or two zeros. That's one that looks like this, where it crosses twice. Okay, now remember, the special words are solutions, roots, zeros also mean x-intercepts. So even like on the last one I did there, there's only two x-intercepts. Doesn't matter about the y. We don't care about the y here like we care about the y-intercept with linear. In a quadratic, we care more about the x-intercept. Our next characteristic is domain and range. And we talked about this at the beginning of the year, but domain, if you remember, for a parabola is almost always going to be all real numbers. The only time it's not is if you happen to have a special situation where you're looking at a real world situation, basically, and so it doesn't involve the negatives or something like that. All real numbers, remember, can be written like, you can write it out, you can write it in this form, or you can simply just write that double R. No matter what kind of parabola you look at, whether it's like this or like this, either way, going left to right, it's going to continue going on and on and on forever. The range is a little bit different. The range is actually very simple here, depending on which type of parabola we're looking at. If we're looking at one like this, well, the range is going to be any point above that bottom. So in this case, we would say the range is y is greater than, because it's above, the y value of the vertex, whatever the vertex is. In this case, if the vertex was 0, -5, then the range would be y is greater than or equal to -5. So make sure you know that the range is greater than or equal to, because the vertex will hit that point. And then if the vertex looks something like, or the parabola looks something like this, it's going to be y is less than, and again, the y value of the vertex. So in this case, if the vertex was, let's say, -3, 5, we would say that the range would be y is less than or equal to 5, because it's everything below 5. Okay, this next diagram, which we're going to put it all together just to make sure we know what all the different characteristics are. First of all, this center dotted line is the axis of symmetry. The bottom point in this case is the vertex. And remember, the vertex is an ordered pair. Okay, do not forget, if I ask for the vertex, you cannot say just 7. In this case, you would say 0, -4. Or actually, sorry, -2, -4. And then finally, the other 2 points are the roots, the solutions, the zeros, or the x-intercepts. And yes, write it down twice. You need to have these memorized, because nothing worse than being asked what the solution is and you can't remember what a solution is, and it's simply another word for x-intercept. You need to make sure you know all these words backwards and forwards, so if you read it, you know exactly what to think. And now finally, I want to mention the 3 different types of quadratic equations we're going to work with. First of all, standard, which you've already worked with before. We've already written on the front, but I'm going to give you another example, like y equals 3x squared plus 8x minus 9. That would be a standard form where we have an a, b, and a c. In this case, A would be 3, B would be 8, and C would be negative 9. Sorry. We also have what's called vertex form, and if you probably think about that for a little bit, you realize what that means is that the vertex can be found in this. The vertex form is this: a times x minus h squared plus k, where the vertex is actually hk. So you can look at this and take out the vertex. Now, because that h is a minus and inside parentheses like that, remember, almost everything inside parentheses, you take the opposite. But I'm going to give you an example of that. Let's say y equals 2 times x minus or 4 squared plus 11. That would be a one in vertex form, and the vertex for this one would be 4, 11. There we go. And then finally, we have one what's called factored form. That's something you're going to hear a lot of here in a couple of weeks. We're going to be factoring. We're going to be taking something like the standard form and rewriting it in factored form. And I'll show you how to do that pretty easily. It's what we use the old school calculator for and all those factors, so we can do that without having to go through some of the processes I teach you, or just you start noticing how to do that very quickly. It's a very important skill that you will use all the way through. But anyway, I digress. An example of that might be something like y equals x plus 7 times 3x minus 5. And so that is something that is factored from a trinomial, which, again, words we'll get into later. Okay, so there go your notes. Have those with you. Have those filled out. Make sure if you have any questions, ask them when you come to class next time. And we will be able to, by watching this, we'll be able to just jump right into finding and working with it. And now that we know some of these definitions, so make sure you have if you have questions, make sure you ask them when we get to class. Thank you.